Let us solve this first order differential equation. Y tan x dy by dx is equal to 4 plus y squared sec squared x. So, how about you go ahead and solve it? Pause the video, write it down, and then solve it, and let's see. Okay, so you solved it. What did you get? Let us see what happens here. So remember now, we're going to separate the variables. You're going to have y and numbers, dy on the left equals x and numbers, dx on the right. So it's a function of y dy equals a function of x dx, and then we integrate. So what happens here now? Let's see. Suppose we divide both sides by tan x. We'd have y tan x, alright, you should remember. The tan x would be under here, and it would cancel this, right? So you should see that the tan x would be gone, and you have dy by dx equals, and you divide this by tan x as well. 4 plus y squared sec squared x, and this would be over tan x. Now let's divide both sides by 4 plus y squared. The 4 plus y squared would be under here, and we cancel this, right? You see that? So we divide by 4 plus y squared, which means that this 4 plus y squared would go. So we have that, and this would be over 4 plus y squared. Alright, then before we go to that, let's neat this up a bit. Put the x squared x directly over the tan x. Then after that, we multiply by dx. This would be dx. You know, dx, it would cancel itself over here. You would have dx, and it would cancel. So that dx over here would go. So you have y over 4 plus y squared dy equals sec squared x over tan x dx. Alright, so we have it all set up now, and we're ready to integrate. The integral of this is equal to the integral of this. Integral of y over 4 plus y squared dy equals integral of sec squared x over tan x dx. Now, let's see how this one is going to go. Here, this would require integration by substitution. So, integrating y over 4 plus y squared dy. Let me write integrating this. We're going to look at this later on. Now remember, as in exam, you clearly show the steps that you're taking, so that whoever is marking can quickly and easily see what you are doing, and not have them wondering what is this for. Alright? Answer your questions in exam, so that somebody can take your paper and study and learn the maths. Everything should be clear, show all working. So we're integrating y over 4 plus y squared dy. Let u be equal to 4 plus y squared. And du by dy equals, remember it's a function y, not x. If x was there, it would be du by dx, but this is y, it's du by dy. So what happens now? This is 2y, this would be 2y. So dy would be equal to du over 2. Alright. So dy would be equal to du over 2y, I mean. So substitute it here. What we have, my, is following. What we have is the integral of y over 4 plus y squared, which is u, over u, and du by 2y, which is a dy, right? But y cancels y. So this would be, this, you have this over 2. This, you can write it as the integral of 1 over u du times half. But that half, you could put it behind the integral sign. So what does that give you? It gives you half ln u. But u is 4 plus y squared. So it is half ln 4 plus y squared. So that's what you get on the left hand side. Alright? Let's look at what happens on the right hand side now. Let's give it a little space and write it over here. Integrating. So we have sec squared x over tan x dx. So we have the integral of sec squared x over tan x dx. How do we deal with that one? Again, it's substitution. Let u be equal to tan x. Du by dx equals, remember what you get when you differentiate tan x? You get sec squared x. Alright? Then what is dx now? Dx is equal to du over sec squared x when you transpose this. Now, what we have is the integral of sec squared x over u, which is tan x. Remember, u is tan x over u dx. But we're going to replace dx with du over sec squared x. See that? And then what happened? And the thing is, you know, if you remember your if you have been practicing a lot of integration by substitution, it will be easier for you, right? You would quickly remember what this should be. You see that sec squared is equal to sec squared x, so you have the integral of 1 over u du, which is ln u plus c. I put the plus c now. This is over the right. This amounts to ln tan x plus c, because tan x was u. So this is the right hand side. So let's put them together now. What we have is half ln 4 plus y squared on the left hand side equals, on the right hand side, ln tan x plus c. Right? Now the fact is, you have a solution there, but Let's simplify it and see how we could simplify it. What we have, suppose we multiply everything by 2, we would have ln 4 plus y squared equals 2 ln tan x plus c. C is a constant. Let us write everything as ln. So c is just ln of another constant. Let's say c is equal to ln a, or whatever it is. Ln 4 plus y squared equals 2 ln tan x plus ln a. It's a strategy to put them together. So what we have is that ln 4 plus y squared is equal to 2 ln, well, it's 2 ln, say, tan of x, of ax, because the fact is, when you have, not ax, you can't trouble the a, it's a times tan x. When you have tan, or when you have ln of a number plus ln of another number, is the same as ln and multiply the numbers. We can just quickly review that and see. Suppose you have 5 by 3 is 15. So we say ln 5 plus ln 3 equals 2.708 and so on. Suppose now we say ln, open bracket, 5 times 3, close bracket, equal. You get the same thing, right? So that's just a reminder there. So what we have is ln tan x plus ln a, the same as a tan x. We keep the 2 there. Alright, so what do we do with this now? Remember, when you have the log 2 times the log of a number, is the same as the log of the number squared. We can try that as well, just to remind us of how it goes. So here, let's say you have 2 times ln 6 equals 3.535 and so on. What about 6 squared? 6 squared is 36. ln 36 equals, is it the same thing? Let's see. So that's just one example. So you have to remember your laws of logarithm. So what you have is ln 4 plus y squared equals, say, what you would have here is tan squared x, right? So it's ln a tan x, or squared. But when you say tan x and you square that, it means tan squared x. Alright? Now, e to the ln, a number, give you that number. And we can see and get an example to remind us of that. Remember, we had shown the solution already, but we're just neating it up. Alright, e raised to the power of ln 3 equals, oh, we get 3. Suppose we had e raised to the power of ln 4, what would we get? 4, and so on. So e to the power of is the anti-logarithm, and ln, the number, is the logarithm. So the anti-log and the log cancel each other. Just like how square and square root cancel each other, and so on and so forth. So e to the ln, that equals e to the ln, all of that. So therefore 4 plus y squared is equal to a tan squared x. So now we could say y squared is equal to a tan squared x minus 4. Alright, you could even want, if you want, write it as y equals square root of a tan squared x minus 4, or whatever the case is. But y squared is a tan squared x minus 4. Alright, so that's our solution. Or I could say the simplified solution. Because when you had this up here, right, this here is a solution, half ln 4 plus y squared equals ln tan x plus c. You might be forced to write it like this. If you get the question and it says show that the solution is y squared equals a tan squared x minus 4, then you have to go through simplifying it, right? But if you're asked to solve, and especially it is in exam limited time, then you could show here that this is what you get.